The program combines three key disciplines: mechanical engineering, electrical engineering, and computer science, especially for the control theory part. It's targeted to the students that are interested and that has background at least in one of those disciplines.
We have learned a little about how to do scientific research. We have learned to solve mathematical problems by using MATLAB. We have also learned a little about reliability based design process.
Program brings, firstly holistic, and interdisciplinary view on the problem. So it also means that it requires a lot of hands-on experience just to make it happen, because everything where you have automation and everything that when you have something that has to move, operate, optimize the actions, it counts. So process automation, also things that are more specific to Finland, like heavy machinery industry, forestry engineering, there are also paper factories and many others.
The most important and also interesting thing that we have learned is simulation. We can just model, for example, a pendulum, and then we can insert it to the simulation and then connect it with, for example, joint, and then apply an external force and see how the pendulum moves in a virtual world.
All the machinery is running currently on diesel engines connected with hydraulic actuators. We would like to electrify them as well. This brings a lot of challenges for everything. So starting from the design to control, and then we are in practice changing all the traditional designs into robotized versions.
We repeat this process until the simulation is satisfying enough, and then we can start to discuss about manufacturing the actual first physical prototype. This can be applied to even further than just modeling and simulating simple parts, like, for example, to the conveyors or even excavators. It's more cost efficient when there's no need to build a first physical prototype to see all these unwanted things and then modify the design. And well, then of course it's more sustainable.